Okay, hey guys, so just recapping what we know about vectors so far is if we've got a vector that goes like this, for 2a, it's that vector plus that vector again, so that whole thing there is 2a, and by the way, I'm redoing this because someone was playing with my board before and they've unplugged my mic, and I came out sounding like Darth Vader. It was funny, but you don't need to hear that. So we also know that if we've got this vector going like so with b, minus b goes the other way. If I wanted to add my vectors together, we have to start with A going up here. All right? Don't know if you can see that. So A going up like so. And the B has to join at the end of A. It can't join here, right? It has to join at the end of A, goes here. And so this one is AB. And again, the direction is very important, that AB goes that way from where it started to where it's finished. You can't say, oh, just where I ended up and then go backwards that way. Right? Not that way, because that would then be minus A take B. So direction is really important. Tip to tail. So again, you start here, you go there, we go then maybe there, then we can go there, carry on. It's always tip to tail, and then your end product is from where you started to your end there. Okay? So that's your finished bit. It would be like A, B, C, D. So this one here would be A plus B plus C plus D. If we ended up that C had a different direction, so C was actually now going that way, it would be A plus B, and because we wanted to go that way, then we'd have to say take C plus D. Alright, so direction, direction, direction. Alright, we went on here and we tried this question, so maybe don't look at the answers and try it yourself. So we've got ABCD as a square. AC intersects, let's get rid of that, we could do it again. So we've got AC intersects at M, so AC, oopsies, white's not good, is it? AC, and then we've got BD, and the lines intersect at M. Alright, and I've labelled their vectors here. We want CD. So could you make sure that when we're going C here to D, you actually use the values here. So CD would be up here, and here. So if we're going up that way, it's C to B, right? Plus B to A, plus A to D, and we get back to where we started, and that's my CD. Well, not where we started, but the end of CD. Notice the innards are the same, BB, AA, and what's your outside? CD. So what is CB? It's minus Q, not Q, because Q is going that way, minus Q is going that way. Okay, again, minus P, and then this vector here, A to D, is the same as that one, so it's Q. They will cancel out, we get minus P. And then you should realise and go, oh, minus P. It was the same up here, so I didn't have to do all of that rigmarole. It could have just been minus P. So always look to see what you can do. AC, right, once again, so we're now going, let's get rid of that one. And we're going AC. Please feel free to fast forward if you've got this. So we've got A to C, and again, direction here. So A to C would be A to B plus B to C. A to B, B to C. That's why we're AB plus BC. AB was P, BC is Q. Bang, done. Okay, AM, remember M was this point in the middle here. So AM, halfway through, so it's half of AC. So again, make sure you are writing this stuff, okay? It's half AC, and then you say half P plus Q. Don't just go straight to this, otherwise I'll dock you. And then you can have a read of BM. If you don't understand, let me know. Alright, now we want to get into the actual tactile stuff, because we said you can now have a go at the last question of that exercise. So this is all on page, sorry I forgot to tell you the page, I did on the first go. This is now us going again. So over here, where's it gone? Here it is. So page 13 of the PDF that you've got. You can have a go at number 5, check your answers, see how you go, and message me if you can't, if you're struggling. So the next bit that we are looking at Again, we did all of this and it didn't record properly, so I apologise. But c'est la vie. So we're representing vectors. How do we represent? So if we've got a vector here, so start with over here. Right, sorry, it's a busy page. This is what we did in the lesson. So if we've got A is 3, 4, that's how we represent it. Or I prefer with the square brackets. And this 3i plus 4j, that is what we call component form. All right, now each one of these, the I and the j, is a unit vector. This is your horizontal vector of 1 unit. So if we go across here, that bit just there, should do it in a different colour. So that bit just there is going across to 1. That is 1, 0. And we can, and j obviously is if we go up here by 1, that's j. So we can make all of these vectors just by multiplying these and adding them together. Okay, so we've got 3i, so 3 times that gives you the 3 plus the 4 times this component, add them together. That's why you call them component vectors. Each one of these is a unit vector, and that's a definition that you want to put down. A unit vector is a vector that has length 1. Okay, so we drew our vector A here, so went across 3 and up 4. We just had that line there, and the question was, how could we find its length? So people were pondering a little bit until I drew the dotted lines in, and I hope that you now are also going, oh yeah, it's Pythag. So 3 squared plus 4 squared gives me this squared, and we know that that's your 3, 4, 5 triangle, because 9 plus 16 is 25. The square root of 25 is 5. So I asked them, can you now write that down as a rule? All right, make a conjecture for how you find the length of a vector. So this was our rule. Now over here. This did seem very organised when we were doing it in class, but as I said, going back and redoing the video, hell's bells. So how do we find the length of a vector? If we've got a vector that's got a component a1 and a2, we squared each one and then took the square root. This is how we represent the length of a vector. They're called modular signs, absolute value. And of course, instead of saying find the length, I could say find the magnitude. It all means the same. Okay. The next thing that we asked was that, okay, what if I had my vector that was 3, 4, but I wanted a unit vector that was in the same direction. So in other words, I want this whole vector here is length 5, but I want it in the same direction, but I only want it to be length 1. How could we do that? And some bright spark in our class said, we'll just divide it by its length. And that's what we did. So if we divide 3 by 5, because remember this length was 5, 3/5 and 4/5, right? We're saying that has now a length of 1. And if we check it out, right, remember that's what I will represent by the length. We go, what's 3/5 squared plus 4/5 squared? So when you're squaring a fraction, you square the top and the bottom. 3 squared is 9. 5 squared is 25, and etc. You get that? So 9 25ths plus 16 25ths is 25 25ths. 25 divided by 25 is 1. Square root of 1 is 1. So yay, that is now a unit vector that is in the same direction, right? In the same direction as A. I then said, well, what if I said, instead of same direction, what if I said parallel? So that's what this green one is here. So it might be going in the other direction, but it is parallel, okay? So what could we mean then? That would mean we could have plus or minus, because it would be going in either direction. So you need to make yourself a little bit of a note here about how we can do that. Oh, and sorry, this was our conjecture, our rule for how do we find the length, a unit vector that's in the same direction as a particular vector. We take this vector and we divide it by its length. So you can either write it like this by timesing it by 1 over a, where we're 1 over its length, or you can divide it by its length here. I mean, this just seems a little bit neater, that one, but if you want to write it like this, you can. And so then we said, yes, parallel work will be plus or minus. So write yourself that down in a little note. And then the next question was, what if I wanted it to now be a specific length? So I don't want it to be 1 unit, I don't want it to be 5 units, I want it to be in the same direction, but now I want it to be, let's say I want it to be 7 units long. How would we do that? So have a think. And again, someone in the class was saying, well, if we've got the unit vector that's got a length of 1, couldn't we just times it by the length that we want? And that is absolutely correct. So if I want a specific length of a vector, I will find its unit vector, so I find its length and divide it by its length, and then I will times it by whatever length that I want. So if I wanted a vector that was in the same direction as A, but it was 11 units long, then I would times this unit vector by 11. Bang, done. So can you make some notes, write it yourself. I want to see that you can do it in your notes page about the yellow here, so you want the yellow down, but then I want you to add some notes about how you can find a vector that would be parallel to that unit vector and also of a specific length. So stop the video and do that. Okay? Onward. We were looking at 3C. And they're saying illustrate the vectors in component form and unit vector form. So component form is this form. Unit vector form is with the i's and the j. So it's not saying find the unit vector. It's actually saying just use the unit vectors, I and j, to write it. So no surprises here. Right, 7, 3, because at the start we've gone across 1, 2, 3, 4, 5, 6, 7, and then we've gone up 3. And that just becomes 7i, 3j. So hide these other ones, and please turn to page, oops, onward we go. Please turn to page 15, and we're going to complete exercise 13C. So we did question 1. So stop the video, do that. You can check now. Did you get those answers? Or you can check with the back of the book. We use beautiful colour. We said don't worry about question 2. You should be able to do it, but write each vector in unit vector form and illustrate it using an arrow on a diagram. So we already knew this one. That was 3, 4. So that's got a unit. Illustrate each unit vector in unit vector. Right, 4. So that would be 3i plus 4j. This would be just 2i, and so on. So we went, yes, stuff that. Question 3. Okay, once again, find in component form and in unit vector form. We just picked one. We went with the first one, BA. So again, it's a direction is important, B to A. So we went across 1, 2, 3, 4, and it was to the left, hence it's minus, and down 1, so minus 1. And someone else who picked CA. So agree with us. Maybe you do another one and check with the back of the book. Again, it's pretty quick because, sorry, as I did this with the class, I'll say again, it came out sounding like Darth Vader, so I had to do it again. Go back to C. Question 4, we just did verbally, write in component form. So be 1, 2, minus 1, 3, and so on. And that's where we now get straight into exercise 3D. Find the magnitude, so in other words, find the length of these vectors. Now we already did that, 3, 4. That would be the same. Someone did say minus 5 because of the minus, but no, remember distances can't be negative. It's 5 meters. You're either 5 meters to the left of the door, 5 meters to the right of the door. It's not minus 5. So those would both be length 5. Again, 3 squared plus 4 squared and so on. This one, we didn't even bother using that rule that we had because 2, 0 looks like this. It's horizontal, 2 units across, and so it's length of 2. So that's just going to be equals 2. So don't bother. Now with this one, we will have to whack in Pythagoras' theorem and use our rule. Right? This is, remember, our rule that you've got written in your notes. So it's minus 2 squared because you go across minus 2 and then up 2. So we want this length here. So minus 2 squared plus 2 squared, blah, blah, we get 8. And we talked about if you look in the back of the book or you pump it in your calculator, you get 2 root 2. So we went through and we revised about how we simplify a surd. You got to look for a square number that goes into 8. Square numbers are numbers that we know the square root of. So 4, 9, 16, or they're all square numbers because they have integer solutions to its square root. So you agree 2 4s are 8, square root of 4 is 2, that's how we get 2 root 2. Bang. And for E, we didn't have to bother with that formula because, again, 0 minus 3, it's down here, and that's just got a length of 3. Not minus 3, but 3. And we are onwards here. Okay, you will keep on going. What did we do? Yep. Find the length of, so again, that's doing definitely Pythagoras' theorem, so 1 squared plus 1 squared all square rooted, so make sure you do it. Which of the following are unit vectors? So again, what is a unit vector? It's a vector that has length 1. So find the length of each of those using your length formula, and if it equals 1, huzzah, it's a unit vector. If it doesn't equal 1, then it's not a unit vector. And please keep in mind what we were looking at before is that when you are squaring fractions, right, oops, where'd it go? Back here. No, one more. When you are squaring fractions, make sure, right, you square the top and the bottom. So 3/5 squared is 3/5 times 3/5, and that's why we get 3 3s are 9, 5 5s are 25. Okay, so please make sure that you adhere to that. Use your calculator if you're unsure, but should be able to do it without. Anyway, and so we're going on to 2, 3, 4, 5. Please finish. The next section, very, very tricky stuff. Okay, so when we are adding, instead of having to draw the diagrams now, we're just doing it in component form. So when we add P plus Q, very difficult. Oops, I skipped the adding. But when we're adding, right, A plus B, 1 plus 4, oh my god, that's 5. Minus 3 plus 7, right, 4. That's it. And when you are subtracting, you think it's going to be even harder. No, it's not. 1 take 3 is minus 2. 4 take 2 becomes 6. Do you have to have that in there? No. But what's going to happen is there will be soon some other letters in here. So make sure that you do know the process. And so I'm asking you to carry on and do 2E. Now question 1, 2, and question 1 and 2 probably insulting you. So probably just do the last 2 questions and I'll be happy with that. And keep working your way through. When you come to question 6, 7, you have to do every single one because they're trying to show you some relationships there. Okay. Question 4, you could probably just pick 2 to do if you want, or all of them. It's up to you. But we're just working our way through. Thanks. Sorry about the video not working